Okay, so we're asked to consider the definite integral given here on the interval from 0 to 1.5. We know that x is somewhere between that. Draw a diagram of the function and shade the area represented by the interval. So let's start off by drawing the diagram of this function. So we add a graph page. We need to go in here and, go in here, enter our function. Now it says 3 minus 2t. We can't graph 3 minus 2t on the calculator. What should we enter on the calculator? Yeah, we have to 3 minus 2x. You've got a bit of variable shift in this one, because there's an x in the problem, which isn't the x that I'm entering here now. So you've got to, it's a little tricky. Make sure you keep that in mind. So it looks like this. We want to find the point 1.5. I think that's going to be that point there, isn't it, in the diagram? Let's just check that is with find the 0. It pretty much looks like that's going to be it. Yeah. So our diagram is going to start off with some axes. Like this. Our line. Remember that our function is defined from 0 to 1.5. So our function looks like this. Our function looks like this. We're then asked to shade the area represented by the integral of that function from 0 up to some point x. We don't know what x is. X is some point between here and here. It can be anywhere. So x could be this point here. This could be the point where x is. So that would give us something looking like this. And then we would have to shade the area like that. So this red line can move. It can move from 0 up to 1.5, and the area can grow. What value of x will give the smallest area? 0. What value of x will give the largest area? 1.5. We can go backwards and forwards on this one. So that's part B. Next up, we need to use antiderivatives in order to find an expression for this. So we can see how the problem looks a little bit now. So what we need to do next is, so this is part A, here's part B. We've got the function, the integral from 0 to x of 3 minus 2t with respect to t. That's why this dt bit here is important. We often have dx at the end. We have to say what variable we're integrating with respect. We're integrating this time with respect to the variable t.
Here on the graph, how did you decide that x was going to be there?
I haven't.
Oh, it's just like a...
It's symbolic that it moves. So I don't know whether it's 0 or 1.5. So it's allowed to vary. So you don't want to show it at 1.5 or at 0 because you don't really symbolically show your understanding. It's somewhere in the middle. Yeah, we will later. Not this. So next we have to integrate this. So remember, we do square brackets. What is the integral of this? 3 minus 2t. Now, you have to use the correct letter, no? It's going to be 3t. Remember, we're integrating with respect to t. You guys want to close the computer there? Let's say what is the integral of minus 2t with respect to t? Yep. T squared plus or minus?
Plus.
We've got nothing getting rid of the minus that's there in front of minus 2t, so it's going to be minus. What are the limits of integration? What's the lower limit of integration? 0. And the upper limit of integration? X. So this is equal to, remember, we insert the upper limit of integration instead of the variable. So that will give us 3x minus x squared. And then here we insert the 0. That will give us 3 times 0 minus 0 squared. Simplifying that second bracket is just going to disappear, isn't it? This is just zeros in that one. So we're going to be left with 3x minus x squared. So this is a function that's going to describe the area. As this x here moves up and down, this will actually give us the area that is sort of shaded. So the smallest area we said when x is equal to 0. So if we insert 0 into here, we'll get 3 times 0 minus 0 squared. Yeah, it's got no area. If we put it at 1 in here, we'll get 3 minus 1, so 2. When x equals 1, the area is going to be 2. And at 1.5, it's a little bit bigger.